We're going to look at logarithmic functions now. So logarithmic functions are actually the inverse of those exponential functions. So if you look at these two pictures below, the blue function are the exponential functions, which we've already looked at, and the red ones are what your log functions are going to look like. So when the base for your log is greater than 1, you have the graph on the left-hand side. When your base of your graph is between 0 and 1, so like log base 1/2, log base 2/3, when that base is in between 0 and 1, you have the graph over here on the right-hand side. It changes the position and the direction of which it goes. So what happens with log graphs is we actually end up with vertical asymptotes for these. And that's sort of what I drew on the graph there. So vertical, they're going to go up and down. And because they're inverses of the exponential functions, remember we said inverses are when the domain and range switch. That's kind of what happens with the domain and range of these log functions. So the domain of these functions is going to be from the vertical asymptote to the right. There's never going to be anything on the left-hand side of that vertical asymptote. So you should never have points that are on the left side of that. So that means the domain's always going to start at that vertical asymptote and go to the right. So for the range of these functions, it's always going to be negative to positive infinity. They're continuing in the vertical direction both ways. So there's never a stopping point in that direction. So range for these will always be negative to positive infinity. So how do we find the vertical asymptote? Well, the vertical asymptote is just found from solving for the argument or that big part in parentheses of your log. So if you guys solve for x minus 4 equal to 0, x would be 4. So you would have a vertical asymptote at positive 4. So that would be like over here. So you would have nothing on the left. So that means your domain would have to be from 4 to positive infinity. From vertical asymptote to positive infinity every time. So here, 5 minus 2x, if we solve for that, we would subtract the 5 over and get x divided by negative 2, get x equals 5 halves. So vertical asymptote at 5 halves, or 2.5, I guess we could say. So the domain would be 2.5 to positive infinity. And we're using parentheses just like we did for our horizontal asymptote because asymptotes are just sort of boundary points, our boundary lines. We are approaching that value at that horizontal asymptote, but we're not really reaching it. So we're always going to use parentheses, never brackets. And then your last one, you guys would have a vertical asymptote at negative 2. So your domain would be negative 2 to positive infinity. Always that vertical asymptote to positive infinity. And that's it. So if nothing else, even before you graph it, you should be able to identify the vertical asymptote of your function and the domain and range of your function.